this video, we're going to prove the following fact. If 1 is added to the product of twin primes, then the product is a perfect square. Well, I'm going to prove something much stronger. Let x be any positive integer. Okay. If I take x and I multiply it by 2 more, because twin primes differ by 2, and then I add 1, I get x squared plus 2x plus 1. And look at that. This is x plus 1 squared. X is an integer. You add 1 to it, you get an integer. So the product of two numbers that differ by 2, when you add 1 to it, is a perfect square. Now, since the conclusion, the product is a perfect square, worked for two integers of the correct form, they differed by 2, then the conclusion is valid for twin primes. For twin primes. P at least 3. Okay. Well, is that even true? 3 and 5 differ by 2 and they're primes. Well, yeah, of course it's going to work because it always works. So P doesn't even have to be bigger than 3. P can be 3. Now, this proof is much better than the proof I'm about to do, because I proved it for any two integers that differ by 2. I multiply them, I add 1, I get a perfect square. Okay, but let us do a proof using prime numbers. Okay. If P is prime, then P is of the form 6m plus or minus 1. If P is 6m minus 1, then P plus 2 will be 6 of the form 6m minus 1 plus 2, which is 6m plus 1, which is good. If P is of the form 6m plus 1, then P plus 2 will be of the form 6m plus 1 plus 2. That's not one of their two forms. It's not one of the two forms. This cannot be possible. P is 6m minus 1. P plus 2 is 6m plus 1. Okay? So 6m. So let's write it. P times P plus 2 plus 1 is 6m minus 1 times 6m plus 1 plus 1. But these are conjugates. Gives you 6m squared minus 1 squared, which is 1. And then when you add 1, that cancels out, so you get 6m squared. And there's the proof. Just write it up a little bit cleaner. If you take P, you multiply it by P plus 2, and then you add 1, you get P times P plus 2 plus 1. And that ends out up being perfect square And that's the end of this proof. So let's see something. Didn't look to be much shorter, but the conclusion is lacking. This conclusion is you only get a perfect square if you have twin primes. Here we concluded that for the product of any two integers that differ by 2, if you add 1 to it, you get a perfect square. So there's no reason why it wouldn't be valid for p and p plus 2 both being primes. You'll still get p plus 1 squared. Okay, you still get the same. I mean, I could have done an alternate proof. I could have taken p, I can multiply it by 2 more, and then add 1, and then I get p squared plus 2p, that's this, plus 1, and say that it's p plus 1 squared. Okay, and this probably would have been the shortest proof, but again, it doesn't say as much. This says if p and p plus 2 are twin primes, then when you multiply them and add 1, you get a perfect square. This up here, it wasn't that long. In fact, the proof really ended in 2 lines. But then we had to go on to say that it works for any integers. You know what? I'm going to change this one. What I wrote was also valid. Suppose p and p plus 2 are twin primes. Note that p and p plus 2 are integers. So p times p plus 2 plus 1 is p plus 1 squared by above. All I'm doing is letting x be p and x be p plus 2. X plus 2 be p plus 2. Okay, so I actually showed you 4 proofs. If you like seeing multiple proofs, subscribe to my channel, as all we do here are mathematical proofs. See you guys in the next video. Don't forget to watch and learn.